Hey, fabulous pre-cal students. We're starting our unit on algebra basics today with assignment 13. Um, and what we're looking at today are exponents. And I really want to dig deep. I really want to talk about, middle school exponent rules, Algebra 1 exponent rules. I really want to see if we can get really comfortable with all these rules. If we were in a Zoom, I'd have you and a partner in a breakout room figuring these out. If we were in class, I'd ask you to brainstorm with a partner how to do these. But since you're watching an instructional video, I'm just going to say, hey, so, why don't you pause the video and see how many uh, rules you can come up with for dealing with exponents. I've got 8 on my list. So see how many you can come up with and, give it a couple minutes. When you're stuck or done, play the video again and let's share. Okay, so my first one is a to the m times a to the n. When the bases are the same and I'm multiplying, I can add those exponents. Likewise, if I see addition up here, I can go backwards and split that into 2 expressions, a to the m times a to the m. So this works both directions. All right, and so let's give an example of each as we go. 3 to the 4th times 3 to the 2nd equals 3 times 4 plus 3 to the 4 plus 2, or 3 to the 6th. 2. If that's our product property, we also have a quotient property. And so when I'm dividing and the bases are the same, I won't add the exponents, I will subtract the exponents. And so if I have x to the 4th over x to the 1st, that's x to the 4 minus 1, or x to the 3rd. Okay? 3. What's my power property when I raise a power m to another power? When I raise a power to a power, I'm supposed to multiply those powers together. So if I have 2 to the 3rd to the 5th, that's going to be 2 to the 15th because I multiplied those powers together. 4, a to the 0. Okay, so here's the thing. I know you want to say this, and that's true, except it's not always true. Except when a equals 0. Those of you moving on to calculus next year, 0 to the 0 power is not necessarily 1. Sometimes it's 1, sometimes it's infinity, sometimes it's 2/3. So yeah, this year we're still safe saying anything to the infinity power is 1, but since many of you will be moving on, I do want to sort of open your eyes to the fact that what we really need here is a not equal to 0. An additional little statement. So a to the 0 equals 1. Anything to the 0 power is 1, is what we used to say. 3 to the 0 is 1. 1/2 to the 0 is 1. 0 to the 0, take calculus and you'll find out. Okay, that's the first 4. Now, what about number 5? So 5 is a b to the m. And that, I can distribute that power and get a to the m and b to the m. Okay, so if I have 4x squared y to the 3rd, I can apply that exponent to each of these. 4 to the 3rd times x squared to the 3rd times y to the 3rd. When I raise a power to a power, we just reviewed that we multiply them. So this is going to be x to the 6th, y to the 3rd. Okay? So I can apply that exponent. However, when I have something like a plus b squared, that is not a squared plus b squared. not. And yet so many students are going to do it. They're just going to go boink, boink, and say, well, that's a squared plus b squared. No, it is not a squared plus b squared. This says you've got a plus b times itself. Come on, think about all that foiling you've done. A squared plus ab plus ab plus b squared. And so you get a squared plus 2ab plus b squared. See, there's a middle term. I don't have a middle term here. This is wrong. Don't do that. Oh, no. So when can I apply the exponent and when can't I apply the exponent? If I see plus or minus in here, I cannot apply the exponent. I have to do the FOIL. Again, no, I don't see any plus or minus in here, then go ahead, apply that exponent. But if you see two different terms connected with with plus or minus, you have to FOIL. Okay, so watch out for that. This applying works here as well. That's going to be a to the m over e to the m. Okay? Again, I don't see a plus or a minus in here, so I can simply apply the exponent. The last thing I want to talk about as sort of our basics is what about negative exponents? So a to the negative m is the same as 1 over positive a to the m. And if we had 1 over a to the negative m, that would be a to the positive m. So wherever it is, if it's on top, it moves to the bottom. If it's on the bottom, it moves to the top. And when it moves, it drops that negative. Okay? Okay, so those are the rules that we're going to be working with. And what I'd like to do is do some speed rounds with you where we review problems really quick and I give a countdown. Okay? So here's the first one. 2 to the 0. 5, 4, 3, 2, 1. And 1 is our answer. How about negative 2 to the 0? 5, 4, 3, 2, 1. This is negative 1. Many students think this is positive 1 because they think this problem is negative 2 to the 0. It's not. Remember, PEMDAS says you have to do exponents before you multiply by negative 1. This is negative times 2 raised to the 0. So I have to do 2 to the 0 first and then apply the negative to it. Okay? If it were supposed to be negative 2 raised to the 0 power, then we have to have that negative 2 in parentheses. Okay? So this is negative 1, whereas negative 2 to the 0 is positive 1. Okay. So, how about negative 2 squared? 5, 4, 3, 2, 1. I hope you got negative 4 and not positive 4. So, remember, we're doing that exponent, and then we're applying the negative. If I saw this, I would have positive 4. But I didn't see that. I don't see any parentheses here. And because I don't see any parentheses, this is negative 4. Okay. How about 2 to the negative 1 to the negative 2. 5, 4, 3, 2, 1. Well, when I raise a power to a power, I multiply, so this is 2 squared or 4. Okay, let's keep going. How about negative 2 to the negative 1? 5, 4, 3, 2, 1. This is the same as this, which, by the way, is the same as this, which, by the way, is the same as this. How about negative 2 to the negative 1? 5, 4, 3, 2, 1. Well, so here, that's what's getting the negative 1. So technically, I'm looking at this. But again, I learned in middle school that we could put that negative wherever. But technically, like this, All right, what's next? How about negative 4 to the second? 5, 4, 3, 2, 1. Excellent. 16. And how about negative 4 to the third, 2 squared? 5, 4, 3, 2, 1. Well, we know that this is negative 4 times negative 4 times negative 4, so that's negative 64. 2 times 2 to the second is 4, and so that gives us negative 256. Okay. What's next? Okay. How about 3y to the negative 2? 5, 4, 3, 2, 1. Great. 1 over 3 squared y squared, or 1 over 9y squared. That's my answer. I hope you had it as well. How is that different from this one? 5, 4, 3, 2, 1. Well, only that moves to the bottom, is how that's different. If I want everything to get the negative 2, then I need the parentheses. If I don't have the parentheses, only the thing with the negative 2 moves to the bottom. So how about x over 10 to the negative 1? 5, 4, 3, 2, 1. So that's x to the negative 1 over 10 to the negative 1, and then I switch each of them 10 over x. Okay, so that's round 1. I've got 5 rounds here. So let's see about round 2. Round 2 says 3x to the third, 2x to the 0 to the third. Can you simplify that expression? Please simplify that expression. 5, 4, 3, 2, 1. So I'm going to say that's the same as 3x to the third times 2 to the third times, when I raise a power to a power, I multiply, so I get x to the 0 there. 2 to the third is 2 times 2 times 2, that's 8 times 3 is 24. And then when I'm multiplying and the bases are the same, I can add those exponents, and so I get x to the third there. All right, how about this one? 3x to the third, 2x to the third to the 0 power. 5, 4, 3, 2, 1. Okay, so all of this stuff raised to the 0 power, we're saying, is 1. And 1 times this stuff is just that stuff. Okay? All right. What's next? There it is. 5x to the fourth over 6x to the third. All right, simplify that expression. 5, 4, 3, 2, 1. So here I get 5/6, but here I can think of that as x to the fourth minus 3, and so that's 5/6 x to the first. Okay, next. 2x to the ninth over 3x to the negative fourth. 5, 4, 3, 2, 1. Well, that's good. So we've got 2/3 times x to the 9, and we're dividing, so we subtract a negative 4. So that's 2/3 x to the 13th power. Now I know many of you like to do this. 2x to the 9th over 3x to the minus 4. Oh, I have a negative exponent. I might as well move it. X to the 9th times x to the 4th. And then you add these exponents together, and you get 2x x to the 13th. And that works fine too. I like doing this because it's a little less work. But I wouldn't mark you wrong for for doing this. It's the same answer. Okay, how about this one? Negative 2x squared to the third, 4x to the third to the negative 1. Please simplify that expression. Okay, so I don't see any pluses or minuses, which means I can just apply those exponents. So I've got negative 2 to the third, x squared to the third, times 4 to the negative 1, times x to the third to the negative 1. So this is going to be negative 8. Raise a power to a power and multiply. This is going to be 1 over 4, and this is going to be 1 over x to the third. So I've got negative 8x to the 6th over 4x to the third, and I can see that's going to be negative 2x to the third. All right? We could have here said, oh, look, the bases are the same and we're multiplying. We can add these exponents, negative 3 and positive 6, to get positive 3. Okay? Remember, if you have questions on any of this, write down your questions and ask them in the group meet or ask them when we have our live Zoom sessions. Okay? Don't not know. Don't give in to, I don't really understand what he did, he went too fast. You know, if that's your response, that's okay, except you need to watch the video a couple of times, and I'm sure you need to be asking a lot of questions. Asking questions is a sign of someone who is really smart. People who are still embarrassed to ask questions when they're in this class, they're going to have a hard time in college because you got to ask a lot of questions in college. It's the smart kids ask the questions, so please ask the questions. Okay, so what do we have next? How about negative 2x squared to the third times 4x to the third to the negative 1. So what would you do here? Well, PEMDAS says I need to work inside these brackets first. In fact, I need to work over here first. I need to apply that exponent. So negative 2 to the third, x to the 6th, times 4 times x to the third. All that to the negative 1 power. Well, I want to tidy up what's here first. Negative 2 times 4. 2 to the third is 8. Negative 8 times 4 is negative 32. And then I have x to the 6th times x to the third. When the bases are the same and I'm multiplying, I can add those exponents. So when I add those exponents, I have negative 32 x to the 9th raised to the negative 1 power. And when I apply that negative 1 to each of these, I'm going to end up with 1 over negative 32 and x to the 9th all on the bottom. Of course, if you want, you can put that negative up here, or you can leave it out in front. The reason why I keep saying that is because sometimes students don't know that they can put that negative wherever they want. And they see it in a place where they wouldn't put it, and then it confuses them. So I'm just telling you, your middle school math teacher tried to tell you, you can put that negative on top, on bottom, out in front, but not all of those places. One of those places is what you can do. Okay, last problem in round 2. 5x squared over y to the negative 2 raised to the negative 4 power. By the way, 5 to the 4th is 625. 5, 4, 3, 2, 1. So it's 5 to the negative 4th, x to the negative 8th, y to the positive 8th. These move, this doesn't move. So I get 1 over 625, x to the 8th, y to the 8th. Okie doke. Remember, anytime you have a question, write down that question, ask that question. In fact, while you're watching the video and you have a question, why don't you, get on GroupMe and send the question to GroupMe so you can get your answer right away. Okay, round 3. B to the negative 3 over a to the negative 2 times a to the third b squared. Please simplify this expression. So most students out of Algebra 2 like to move the negatives. And so they're going to have a squared on top, b to the third on the bottom, a to the third over here, b squared here. They see that they're multiplying and the bases are the same. They get a to the fifth. They're multiplying and the bases are the same, b to the fifth. And that would be fine. Some students like to take it a little further, and that's fine too. I, though, usually think about this problem this way. B to the minus 3 over b squared and a to the 3 over a to the negative 2. And when the bases are the same and I'm dividing, I subtract. So this becomes b to the negative 5. And I have 3 minus a minus 2, a to the 5, and that becomes that. That's probably how I would do that problem. But really, I just need you to simplify it. There's lots of ways to get there. Okay, so how about this one? A to the negative 2 over b to the negative 2 times b over a to the fourth. All right, so if you were moving these, you had b squared, a squared times b to the fourth, a to the fourth. And then when you multiplied across, you should end up with b to the sixth over a to the sixth, or b over a to the sixth. Easy peasy. All right, so then these. These are the ones that people often feel uncomfortable with on the homework or on a test. Okay, I don't see any plus or minus here, so I know it's safe to apply the exponent. 2 to the 3 halves times x squared to the 3 halves over 2 to the 1 half over x to the 4th. Okay, when I raise a power to a power, I multiply. 2 times 3 halves is 3. So I have 2 to the 3 halves x to the third over 2 to the 1 half x to the 4th. So I really find that when I'm in this position, it really helps for me to remember that when I'm dividing and the bases are the same, I subtract the exponents. So I could rewrite this as 2 to the 3 halves minus 1 half times x to the third minus 4. So what am I going to end up with? Well, 3 halves minus 1 half is 2 halves, or 2. And here, 3 minus 4 is negative 1. And so often, by the way, you probably noticed this, our homework or our tests say no negative exponents in your answer. And so that's going to be 2 over x as our answer. Okay? All right, let's do 1 or 2 more of those. How about x to the minus 3 times x to the 1 half over x to the 3 halves times x to the minus 1. Now, there's lots of ways you could do this problem. You could work across first. You could work vertically first. You could move the negative exponents and turn them into positive exponents first. I think what I'm going to do is I'm going to go across. So I know when I'm multiplying and the bases are the same, I can add those exponents. So I get x to the minus 5 halves. And on the bottom, I'm multiplying and the bases are the same, so I'm going to add those exponents. Now, when I'm dividing and the bases are the same, I subtract, and so I get x to the minus 5 halves minus 1 half, which is x to the minus 6 halves, or minus 3, which is 1 over x to the third. Would you like to do it another way and see if we get that same answer? Sure. Most students like to move those negative exponents. So we've got x to the 1 half times x to the 1 over x to the third times x to the 3 halves. Now what you're going to do? You're going to go this way, or you're going to go this way. Doesn't matter to me. X to the 1 half plus 1 over x to the 3 plus 3 halves. I end up with x to the 3 halves over x to the 9 halves And then, oh, I'm dividing and the bases are the same, so I better subtract. 3 halves minus 9 halves. That's going to be x to the negative 6 halves, which, by the way, is x to the minus 3. And there we are again. Okay? Um, you know, I would say that moving the negative exponents was really important for me as an Algebra 2 student. But by the time I become a calculus student, this is going to be much preferred where I think about subtracting the exponents. Okay? All right. How about this one last one in round 3, and then we'll move on to round 4. Okay, so I've got 3 to the negative 2, 4 squared over 3 to the negative 6, 4 to the negative 2. All right, please simplify that expression. Look, see? Look, you're all about moving those negative exponents. Now, you could just negative 2 minus a minus 6 times 4 to the second minus a minus 2. That's going to be 3 to the fourth times 4 to the fourth, which is 81 times 2, 56. And I need a calculator for that one. 81 times 2, 56. And I get 20736. Okay? Um, so the moving, right? Here's what I'm getting at. If you move all these exponents, it's going to take time. You've got to move this one down, you've got to move this one up, you've got to move this one up, and you've got to rewrite the problem. And every time you do, you run the risk of maybe introducing a casual mistake. No, that's not there anymore. That's there. Okay, so I turned everything positive, and now I'm going to add the exponents, 4 to the fourth, and here I've got to subtract the exponents. So some people still do this kind of thing, 3 to the fourth. So we get to the same place. I just don't want to waste the time moving everything. You can move everything. Don't worry that I'm disparaging moving everything. If you need to move everything to feel comfortable, then move everything to feel comfortable. I need you to feel comfortable when you take a test or a quiz. Okay, round 4. 16 to the 1/4. Do not use your calculator. Not a calculator problem. How am I supposed to do this? I want you to rewrite the base. Here, the base is 16. I'm going to rewrite 16 as 2 to the fourth. Oh, look at that. When I raise a power to a power, I multiply them. What is 4 times 1/4? Oh, it's 1. So my answer here is 2. The fourth root of 16 is 2. Right. Rewrite the base. Now, you could say, well, Mr. Gupta, I'll rewrite the base this way. Sure, that's fine. When I raise a power to a power, I multiply them, so I have 4 to the 2/4, which is 4 to the 1/2. Oh, but look, this base can be rewritten as 2 squared. And when I raise a power to a power, I multiply, so I get 2 to the 1 again. All right, my answer here is 2. Next, 8 to the 2/3 power. Again, my recommendation is you rewrite the base. 8 is 2 to the third. What happens when I raise a power to a power? I multiply them. 2, 3 over 1 times 2 over 3. I have 2 squared, or 4. I don't need a calculator to do that problem. I do need to notice that 8 is 2 to the third. It may be useful for you to think about a little table. Four to the 1, 4 to the 2, 4 to the 3, 4 to the fourth. Oh, that's funny. 5 to the 1, 5 to the 2, 5 to the 3, 5 to the 4. So these are really common. When I see these numbers, I know I can write them this way. 8, 16, 32, 64, 128, 256, 3, 9, 27, 81, 243. 36, 5, 25, 125, 625. Okay? Those are the most common ones. You should be familiar with them. When you see these numbers, you know you can rewrite the base this way. All right? So let's take a look at some more of those. This is round 4. 16 to the negative 3/4. So we've got two ways to do this, and I always want the smallest base. So even though I can turn this into 4 to the second, I'm going to use 2 to the 4th, especially because I see this denominator of 4. When I raise a power to a power, I'm multiplying. Those cancel. I get 2 to the negative 3, or 1 over 2 to the third, which is the same as 1/8. This is equal to 1/8. Okay? You will see this in the homework. You will see it on our assessments. So please make sure you're comfortable rewriting the base. 27 to the negative 2/3. You try this one. So did you rewrite the base? 27 is 3 to the third. And then when you raised the power to a power, you ended up with this, which is 1 over this, or 1/9. Okay? How about this one? 8 to the negative 1/3. Try that one. All right, I hope you wrote 8 as 2 to the third, and then when you raised a power to a power, you ended up with this, or 1 over 2. How about something a little more? 125 over 64 to the 2/3. Okay, so now what I can do is rewrite the base. This is 5 to the third, this is 4 to the third, raised to the 2/3. If I apply that exponent to each of these, I'm going to have 5 to the third to the 2/3 over 4 to the third to the 2/3. When I raise a power to a power, I'm multiplying, so those 3's cancel. I have 5 squared on top. These 3's cancel. I have 4 squared on the bottom, so I get 25 over 16. Okay? Please don't pick up your calculator and do this on your calculator. I'll be marking that wrong on the test. I really need you to rewrite the base. Okay. How about 8 over 27 to the negative 2/3? Try that one. Okay, so that's 8. Oh, that's 2 to the third over 3 to the third raised to the negative 2/3. When I apply that exponent, 2 to the third to the negative 2/3, it's going to be 2 to the negative 2, and 3 to the third to the negative 2/3 is going to be 3 to the negative 2. All right, so that's going to flip these, right? So I'm going to have 3 squared over 2 squared, or 9 over 4. You know, you could do this. You could say that's 2/3 to the negative 2. And then you could say, well, I'm going to flip it, so that's 3/2 to the 2, which is 9/4. Okay. Where are we next? Ooh, just about done. 16 over 81 to the negative 3/4. Go! You can do it. Okay. Did you write 16 as 2 to the 4th and 81 as 3 to the 4th? Raised to the negative 3/4. You know, in a problem like this, you might want to do that, because then these will cancel. You have 2 to the negative 3 over 3 to the negative 3, or, as many of you prefer, with positive exponents, and then 27 over 8. Okay, that was round 4. Here's the last round. It's short. It's just one question. 3 to the negative 1 plus 4 to the negative 1, does that equal 7 to the negative 1? Which, by the way, is 1/7. Okay, true or false? What do you think? Well, when I think about this, I've got 1 over 3 plus 1 over 4. And I remember my middle school math teacher saying, you want to add two fractions? You better make a common denominator. So here I have to multiply by 4 over 4, and here I have to multiply by 3 over 3. So I've got 4 over 12 plus 3 over 12, and since they have a common denominator, I can do 4 plus 3 over 12, which is 7 over 12. 7 over 12 is not 1/7. So no, don't do it. All right, I hope this helped, and send your questions to the GroupMe, ask them in our live Zooms, get your questions answered. And by the way, when you watch these videos, my strong recommendation is that you take notes on anything that you don't instantly recognize. If you know how to do all of these problems, you don't need any notes from this video. But if you only got half of them right or a third of them right, yeah, I'd watch this video again and take notes if I didn't the first time. All right? Well, I hope you have a great day, and I look forward to your questions. Remember, this is, I believe, assignment 13, the first assignment on our Algebra Basics unit. Okay, Algebra Basics unit. Oh, I got the assignment calendar right here. Yep, it does say 13, and that's bookwork, and you'll find that scanned, those pages scanned for you already when you go to our Office 365 folder. And you know, even though we've been at this a while, if you don't know how to find that folder, that's another question to ask. Okay? Have a wonderful day, and do your math.